Hi, everyone. This is Rob Gray from the ASU and the Perception Action Podcast. In this episode, I wanted to share with you some results from a new study I completed a little while ago, um, testing this idea that have been talking about for a little while on the podcast. I talked about it in my book. The idea that maybe we can develop a skill more effectively by by actually practicing doing the wrong thing instead of the right thing all the time. So what do I mean by that? Right? So in most sports, and this is a study obviously not surprisingly about baseball, the data I collected, in most sports we focus on doing the right thing. And by that I mean we focus on producing the outcome, the performance outcome that's desired, that's needed in the game, right? So in golf, we focus on hitting the ball down the middle of the fairway all the time in practice. In basketball, we focus on getting the ball in the hoop in practice. In baseball, we focus on hitting the ball hard into fair play, right? So we're focusing on the outcome, desired outcome we want, performance outcome, the right thing. And traditionally, right, if we have deviations from this, right, we correct things, right? And we try to reduce movement variability and all the things we usually talk about, right? So we're focusing on the right thing. Alternatively, I wanted, I've talked about, as I said, I talked about this in my recent new book and a few other places. Maybe there's some benefits to actually practicing the wrong thing. So practicing hitting the ball out of bounds all the way to the left and all the way to the right in golf, practicing hitting the back of the rim and having the ball come back to you in basketball. In baseball, hitting the ball a foul into foul play, hitting the ball directly into the ground, hitting the ball popping up, right? Instead of focusing on the actual outcome we want, a solid contact into fair play, practicing the wrong things, the undesired outcome, may actually be beneficial in practice. Why? The idea is it's going to give the performer more information about the solution space, right? If I understand what it takes to hit the ball all the way to the right and all the way to the left, right? Not on a cognitive level, but on the relationship between my movement and perception and the control of action, right? If I understand that, then I can understand how to hit the ball into fair play, right? I'm learning about how the relationship between my movement, perception, information control law, and the outcome, right? So we're not trying to develop the ideal shot technique or golf swing or baseball swing that leads to this desired outcome in practice. Really, in practice, we're trying to get you to explore and learn about the movement solution space. Right. So I wanted, as I said, I've talked about this idea. So I wanted to test this idea directly. So what I did is we did a study in my baseball batting virtual environment. So people are hitting in a virtual environment. As I've talked about it many times before, it's now has uses a head-mounted display with you have feedback about the hits and things like that. Various different things. The batter gets feedback about the contact of the bat, and the sounds, and so on. So what we did was we took novice batters, so people with relatively limited baseball experience, less than 5 years, because I think this is probably the really particularly beneficial for new learners, getting this information about the movement space. So what we had is we had two training groups. One, I'll tell you more about them focusing on the right things, right? And one, the wrong way training group. And both completed one session in the virtual environment for 6 weeks, right? The training groups were compared to a control group that just did regular practice, baseball practice. Okay, so what were these training groups? So the right way training group, what we did was we gave them every single practice. We gave them the goal of trying to do what you're supposed to do in baseball, the right thing, right? Hit the ball on a line drive into fair play. So hit the ball hard into fair play. They practiced this in the virtual environment. I had coaches involved, right? So giving them feedback, it was either in person or remotely, watching their swing and watching how they hit the ball, and they were giving them feedback about. So if they missed the ball completely, they'd give them some coaching cue or tip, right? So kind of traditional corrective feedback about and prescriptive feedback about how to swing to get the ball into fair play, right? So very standard coaching, right? Well, you swing, you get the outcome you want, great. We can do another rep, right? If you don't, we get some corrective feedback about how to swing to keep the ball fair or not miss the ball, for example. And in this, there was some variability in the conditions. The pitch speeds were varying and things like that. So there was, it's kind of standard batting practice, right? in the virtual environment. And these are some of the kind of cues you give to the batter. The wrong way training group, what we did instead of doing all of that, right? They were given no instructions about how to hit. They were given no corrective feedback from a coach. What they did instead is across the 6 weeks, they practiced, they had different goals, right? So each session they showed up, they had a different task goal. And then some of them, as a reason why I call them the wrong way training group, their goal was to produce an outcome that you actually don't want in baseball, right? So the one of the sessions they had to hit the ball as far to the right as possible. Another one they had to hit the ball as far to the left as possible, which is a foul ball in baseball, which is a strike, right? Another one, they had to try to pop the ball straight up in the air as possible, high as possible. They did actually practice the right thing as one of their conditions. They had to try to hit the ball in the fair play. Then they had to drive the ball into the ground. So at all of these sessions, they're given this goal and they're given feedback. They're shown where the ball goes. They're shown the velocity of the ball. They're given feedback relative to this goal that we've given them in each session. They're not told at all how you produce these outcomes, right? They're just asked to explore. So they, for example, on the far to the right as possible, they swing and the ball goes straight. Then we give them feedback, make the ball go more right, and they try different things. They explore, try swinging earlier, try hitting the ball more out in front. They kind of just explore on their own to kind of produce these different outcomes, right? So that's the gist of it. One group training to always get hits, right, and getting feedback from a coach. Another group training with all these different outcomes, try to produce these different outcomes, which are, as I said, it hopefully is going to make them learn about the movement space, learn what I have to do with my bat to make the ball go straight up in the air, what I have to do with my bat to make it go down on the ground, right? That's the idea. So we compared these two groups. They then did both before and after training. They did tests where basically they had batting tests where they were in a game. They were facing pitchers that threw different types of pitches in different locations. So importantly, sometimes the pitches were on the inside of the plate, close to their body. Sometimes they're on the outside. We also, importantly for this study, what we did was we moved the virtual fielders around, right? So the fielders sometimes all went to the right side of the field. Sometimes they were spread across the field. Sometimes they all went to the left. And they kind of did this based kind of in a game-like manner based on the pitch. So the batters did a whole bunch of these at bats where they're kind of trying to now, obviously their goal now in these tests is to get hits, right? Hit a ball into fair play so it doesn't get caught, or hit a home run, right? And if they missed, they got strikes. They could take pitches. They would be balls and strikes, right? So they're basically playing kind of little games, okay, in these different environments. Okay, what do we find? Okay, so what I've shown here is we have the right group, right grade training group, wrong group, and control group, right? The control group here, as I said, was a pure control group. This is the batting average for the number of hits they got without being caught. This is the number of times they struck out. Okay, this is the slugging percentage, which is a measure in baseball. Not only measures how many hits you get, but how hard, right? How many home runs, how many doubles. What I want you to focus on there, you can see, the right group improved, right? We trained them, right? You'd expect them to improve. Their batting average went up, their strikeout percentage went down, their slugging percentage went up. What I want to see here is the biggest improvements happen in terms of performance in the post test happen for the wrong way group, right? The strikeouts went down further. Slugging percentage went up a lot more, right? They had a lot more home runs and doubles, right? So we got a performance benefit for this wrong way group. Interestingly, and I think this for me, there's lots of reasons you could explain why this happened, right? Part of the thing, I've had a few people talk to me about some of this research on this kind of approach and differential learning. They're saying, how do you rule out the possibility that this is just a novelty effect, right? It's a very different type of training than they've ever done. Well, sure. Okay, I'll accept that's a possibility. That's a benefit, right? That I can't deny that it happens. Doing novel training is good, right? So sure, maybe it is the novelty of the training rather than exploring the movement space that helped them. But this, I think, helps to support my argument, a proposal that it is something to do with learning about the information movement space, right? This is some interesting one. What we did, and this is kind of what we looked at, I'm calling this affordance perception. So this is the number of times they swung at pitches out of the strike zone, which is called the O swing percentage, right? So, and obviously in baseball, you don't want to; those are harder to hit. What you can see is the right training group decreased, the wrong training group. Not only did they get better performance, but they were more selective, right? They perceived the affordance of hitability better, right? Is one way to say it. Right? They swung at pitches that were not as hittable less often. But this is really where it gets really interesting, right? So what you could do, what I did was I measured, right? So the reason I did those inside outside pitches, and this is a manipulation if you want to go back and look at some of my earlier work, I really like, right? The reason I do this manipulation is because different pitch locations afford different types of hitting better or let worse in baseball, right? So if I'm a batter and I'm trying to hit the ball to the opposite field, right, away from where I'm opposite side of the field from where I'm standing, that is much, much easier to do when the ball is further away from me, just by from biomechanics, right? It's just it's very difficult to do, but not impossible to do it when a pitch is really close to my body. I have to do a really weird swing to make the ball go that way when it's close to my body, and vice versa. If I want to hit the ball to the same side of the field as me, which is called a pull hit in baseball, closer pitches to my body are easier. Okay, where if I want to hit the ball, pull the ball when it's really far outside, that's difficult to do, right? But again, not impossible. But what I did with this is I looked at what batters did. So imagine I move all the defense over to the right side of the field, right? And I throw you an inside pitch, right? If I move the batters all over to your this side of the field, the pull side of the field, I throw you an inside pitch, right? Swinging at that pitch is probably not the best idea because the most afforded outcome from an inside pitch is pulling the ball right where all the defense is. And what you can see here, this is the number of times batters swung at the ball in those situations. What you can see is this massive drop in this for the wrong way group, right? So the wrong way group stopped swinging, and you can also see they opposite was true as well. So if I threw them an inside pitch and the defense was all over on the other side of the field, then they were more likely to swing at it. They swung at it more. So it seems to me this is good evidence that they've improved their affordance perception, right? They're swinging more at pitches that afford hitting the ball where the defense isn't. And they're swinging less at pitches that would hit it into the defense, most likely, right? So I think this is really a kind of supports my idea, as I said, that they're learning more about the information movement space. Right, so I think that's a really interesting. And the last one, what I did was so in my some of my previous work on baseball batting, I've done some. I call it a conceptual, in uncontrolled manifold analysis. What I do is basically divide the swing into two halves. Right, there's backward shift in weight and the forward shift in weight, and look at the combination. Right, the idea is that if you add those two together, they have to match the time it takes the ball to get to the plate. Right, so any variation that keeps those two things added up to the same value is potentially good variability. Any variation in the weight shifts that makes it longer or shorter is bad variability. So we can calculate this. And what I found is that you get this higher increase in good variability for the wrong way group, right? Where they get a significant increase in good variability and a significant decrease in bad variability. That is, they have more combinations of this weight shifts, the top, which varies from swing to swing, that stay within the required timing constraint, and less that don't. Right. So evidence, again, that they're developing functional movement scales through this training and exploration of the wrong thing to do. Okay, so to kind of sum up, I think, that encouraging this exploration of movement space, right, by practicing both the desired outcomes you want and undesired outcomes are beneficial because I like to think of them, they're very loud in terms of information, right? When you hit the very ball all the way to the left, you get very loud information about movement, right? The information movement relationship. Whereas if you miss a slightly shot slightly to the left, it's very quiet. It's hard to pick up. Why did that when I shot a ball and it hit the left side of the basketball rim? Why did that happen? Right? What made it do that? How do I adjust my information movement control to improve that and make the ball go in? That's going to be very quiet information, right? It's a subtle change in the outcome. Whereas if I make you miss it way to the left or hit the back of the rim, that's much louder information. It's better information for learning. And so I think this provides some evidence of the benefits of that rather than focusing on technical instruction all around producing the right outcome. Doing the wrong thing sometimes can be good in practice. Right. So as I said, I'm going to present this at a couple conferences, one in Nebraska and then the ICPA conference in Mexico this summer, and then hopefully I'll have more, maybe a paper or something about it later on. So, but I think it's kind of an interesting finding, and again, it's something I've been talking about for a while. So, thank you for joining me. Cheers for now, and keep them coupled.